Hello Chem fans, welcome to my channel on Chemistry Lessons. This is AQA A-Level Chemistry and we're going to look at how cisplatin is used as an anti-cancer drug. This is what it says, so there's your specification. I'll let you pause and read that, I'm not reading all that, but we'll come back to this. Because first up, if you don't subscribe, please do. Your support is very much appreciated, thank you very much. Okay then, so we need to look at what cisplatin actually is, and there's a bit of it links back to your work on transition metals, which you may or may not have done yet. Okay, I tend to have covered DNA before I've done transition metals, but you might have done it the other way around. Just a reminder that you are given this table of information in your data book, and this helps us identify where the DNA or where the base binds to our cisplatin, because we're going to look at that. So we're going to look at how it does this. Okay, so it specifically says, look, a bond is formed between platinum and a nitrogen atom on guanine. Okay, so I've taken my cisplatin, and we'll kind of look at the formula of that shortly, and I've taken my guanine. So some anti-cancer drugs inhibit the enzyme that are involved in the synthesis of nucleotides. And that's what's happening here. So they're preventing the replication. So if they inhibit the enzyme, they prevent the DNA from replicating. And cisplatin, that's cisplatin there, it's a platinum complex. Again, if you've done transition metals, this makes sense. If it doesn't, if you haven't, it doesn't quite. But there it is there, it's a square planar shape, and it's the cis isomer, not the trans. It has to be cis because it's very stereospecific. We saw that with enzymes. So it's stereospecific. And what happens is it acts by allowing a coordinate bond to form between the nitrogen atom in guanine. So it's a coordinate bond. There's a pair of electrons on this nitrogen right here. So this nitrogen right here is a lone pair, and it forms a coordinate bond with the platinum. So it binds to the guanine in the DNA. It can also bond to other guanine residues on the same or different strands. And that prevents the replication of the nucleotides and prevents the replication of the cancer, prevents it from multiplying. So the final section is to look at the adverse effects, and the idea is that we have to make decisions to kind of weigh up the benefits and the adverse effects. So unfortunately, it does also prevent the replication in healthy cells. This means that we stop producing hair and gametes. So that leads to hair loss and infertility. Those are the most common side effects of cancer treatment or the cisplatin. So doctors always make patients aware of these risks, and the patient makes a decision based upon the benefits and those adverse side effects. And that's it for cisplatin. Thanks for watching.